Hello, thanks for watching this walkthrough about the web application we're going to deploy, which is a web application for predicting the Canadian CRS scores. A bit of a background, when you apply to Canada to become a permanent resident, Canada works basically with express entry. And on express entry, what happens is that you have a bunch of different immigration programs. And the gist of it all is that on each of these programs, you must hit a particular score for you to be eligible to apply on the rounds that they select. And this score is called the Comprehensive Ranking System score. It basically looks at different features such as, like your age, your marital status, your education, your professional background, language proficiency, ties to the country, etc., etc. And in general, the higher the score, the better off you are, and the more likely you are for the Canadian government to extend an invitation for you to immigrate into the country. Now, the score is never like a linear sort of score. It tends to have its ups and downs depending on the requirements of the time. So that's why there are like a lot of analysis out there and a lot of like guesses on what would be the next CRS cutoff score, but nobody really quite knows because it's very heavily dependent on seasonality. It's heavily dependent on what is the government focusing on at that time, and amongst other things, how many applicants. It's a bit of a complex problem. So what I'm trying to solve here is, give a reasonable estimate of what will be the next score as time goes by. And so basically now we're going to look at a time series model. Essentially, we're fitting time series based on previous CRS scores on previous invites, being the last one April 24th or so of this year. So we're going to start by basically cloning the Git profile. So I have my Visual Studio. I already have it here. So we're just going to create a temporary folder so that I don't rewrite things. And then we're going to move to that one. And we are going to clone it inside there now. So we're on the side of temp folder. So basically clone, basically we just do git clone HTTPS. So now we have our little CRS Canada MLOps. We're going to move to that one just to make sure things are nice. Gonna open it here. Right. So now you're on the folder, you have downloaded everything from the website. And the next thing is we're going to start looking at the process behind how to deploy this. There are 3 steps. First, we are going to scrape the data from the website, from the Canadian website. We are going to use that to train a model. We are going to analyze whether, a good linear model or an XGBoost model would work well. We are messaging the data so that we can use time parameters and use them as input for these linear models or XGBoost models. Then with the best model that we find, we're going to deploy it into a web app, and then we're going to monitor the behavior of this web app on like a daily basis, because every day that there may be a new round of invites. So that's the goal. So, and we're going to look at a lot of best practices of linting, unit testing, make files, etc. Prior to running any of these, make sure you have installed Anaconda and Docker. and that you have at the very least here Docker running. So for example, I have Docker running here. What I'm running right now is Anaconda 2.52 and Docker 4.33. And first, we're going to deactivate any Conda library, and I'm going to shorten the link like so. So make sure you don't have any Conda environment running right now. Now we're going to do make setup. What it will do is that it will create the Conda environment. It will extract the required packages. It may take longer or slower depending on your machine. It mentions it here, but also what it is doing during the setup. It's that it is converting some important files into executable files, which we will need later. And also it will be moving these AWS credential folders with fake credentials into your root folder. The reason we're doing this is because we are not actually going to use an S3 bucket from the AWS because that costs money. Instead, we're going to simulate an S3 bucket using local stack and a Docker container. And so for that, we just create dummy credentials that match what is inside the Docker container over here. So yeah, just this should match what you have on the AWS file. If you don't want to overwrite your personal Docker credentials, your personal AWS credentials, you can just come here and change these values in the local stack container. And also make sure that when you're doing, we're going to run these next, but when you run these, make sure that these export environment variables are also dated with your particular credentials, because we are going to need these later on. That's one option. Also, there is a note somewhere in here that for Windows users, right now this is set up for Linux/Mac. For Windows users, it won't know well how to copy paste these AWS folders. You will have to do it yourself your own way, or you can follow the instructions in here on how to do that with like a one-liner through the terminal. So now we had make setup. So the next step is we're going to use this setup and file to initialize all the things we need for us to start training models. We're going to create via Docker simulated PostgreSQL database called B. We're going to have a simulated local stack S3 bucket, exporting some environment variables we need. And at the end of this, we should also have activated a conda environment called CRS_M. There you go. Also, bit of a fun fact, local stack now, the free version, does not allow persistence on the data. So now we're creating a volume. Ideally, this would persist the data, but in reality, it won't allow us. If you have the paid version of local stack, then the data will persist, meaning that when you do Docker compose down or similar, your data will be gone if you're free tier. If you're paying for local stack, then your data will persist, even if you bring down the container. So now we did that. You can check if you're having your Docker containers running with simple Docker compose PS to list what's in there. You see we have everything. And you also can make sure that the bucket that you're simulating is in there. This endpoint URL is signaling to the local stack container that we have ported to for 566. So yeah, it says there's a bucket in there. So we're good to go. We're going to start then MLflow and prefect using make start. It will start the servers it will start MLflow on the background. It will also start the prefect server locally on your computer. And then it will also start the automated deployment of the training script. So if you go to MLflow and prefect, oh, sorry, we need to do this first. It has deployed and it will have some logs. Right? There seems to, this should be up to, okay, yeah, it was taking a while. So you should see now an experiment that hasn't had anything yet on MLflow. So basically the server is working. It's also working with a simulated, this is working with a simulated PostgreSQL database, and it is working with the S3 bucket. And now your prefect should be up. There should be a deployment here now. This is the training process that is deployed, and for us to initialize to a first flow run based on this deployment, what we do now is we use make perfect deployment. Okay, so now we have kicked off a flow run, which you should be able to see here on the dashboard. Yeah, there you go. It's doing the thing. And also in MLflow, you should be able to see a bunch of runs. Now I'm running about 20 models total. I'm running 10 linear models, 10 XGBoost models. The linear models are super fast. They take like seconds or not even. Whereas XGBoost models are taking, I'm running this on a MacBook. It's taking about 60 seconds each per take. Reason is because for XGBoost, there is hyperparameter tuning on every single model. That's one. And two, the reason I'm looking at 10 different models is because I am looking at different combinations of variables that may be a good fit for, the description of, the things that may be affecting the CRS cutoff score. So for example, I'm just gonna look at this one. What I mean by that is that the inputs for the models, I'm changing them. In this case, I'm looking at, for example, different rolling windows so that I can convert the time series data into its own independent variable. So in this case, for example, I'm looking at the time delta between the queried data point and the previous invitation round. And the CRS -1 would be the CRS cutoff value that I got from the previous invitation round. This would be the time delta between now and 2 invitations prior. Same thing for CRS2, cutoff value of 2 invitations prior, and so on and so on. That's one type. Another type would be, there might be some rolling windows. This would be like looking at the average value of 30 days prior to the queried data point that I'm looking at, the query time. So that like a month ago, from looking at CRS values from a month ago, looking at CRS values from 2 months ago, 3 months ago, 4 months ago, so on and so on. So I'm looking at which would be a better indicator by just looking at different models. Let's see how this is running. As you can see, linear feeds are really fast. MLflow, XGBoost takes actually longer. You can see here. It's just finished 2 XGBoosts. Now, if you want to read more about the actual data analysis behind this, you can go here into 01_ development and this Jupyter file right here. In this Jupyter file, there's an entire analysis of the data available on the Canadian website. There is some pre-processing, some messaging so that we can actually plot it, visualize it. We look at different metrics like number of invites, which for example would be like a significant one. And then we look at also the actual CRS cutoff. For example, here we're plotting after we scraped all the data from the website, we plot the data and we see that, for example, we have different invitations rounds, and then we're looking at, for example, the general rounds, which is actually the one that we're going to fit towards, because that one is the one where everybody can apply. So that one works. These are more like specific to certain subgenres. And then starting 2023, halfway through the year, the Canadian government added other subgenres in which, for example, if you're fluent in French, you can apply to a specific program for that. If you're a healthcare worker, there's a specific program for that. So and so on with trades, other types of trades. Reason for that is that now the government is shifting to like trying to fulfill specific needs in a particular area. And then there's like something called the provincial nominee program, in which you have ties to certain province via a job offer or similar. So for those, usually the CRS cutoff is higher because job offer automatically grants you something like 300 points. So, by default, everybody has like that baseline. So there's that. You can read a lot more. There's like a whole analysis on that. You can see the effects on seasonality, the effects on COVID. The COVID really did a number on this. That's why you see that massive outlier here that we actually removed because it's declared as an outlier. This is the effect of COVID closures. There's also an analysis on, how we cleaned up things. The actual data looks like this in the end. And one thing to note while XGBoost is running, that we are not doing the usual stuff with time series data, like for example interpolation, because when this thing is not, it doesn't have continuous data sets through time. You have moments where a lot of invitation rounds came out, and then you had like half a year where there was no invitation rounds sent out. This entire section is literally no invitations rounds for COVID, because COVID airports closed. Nobody was coming in and out. So they just suspended the program because nobody could immigrate in a timely manner. And then, yeah, that's one thing. Second thing is that I don't feel comfortable interpolating this type of data because I don't think it translates to an actual representation of how this was behaving. So that's why instead of me doing interpolation, so I could have evenly spaced time points, instead of that, I just converted the variables into its own, looking at the deltas of time and so on. I also analyzed the seasonality, and I went on a deep dive on which models would be interesting to look at. I ruled out a bunch, and then that's why I ended up just looking at linear regression and XGBoost for this particular problem. Yeah, you can go on, have a look. It's quite interesting actually, looking at how the Canadian government is addressing immigration in their country. Let's see how this goes. Still running. It should be 10 more. In total, this should run, if this is a MacBook or a laptop, this should take about 8 minutes. If you're running this on a workstation, then this should go way faster. And heads up, we're going to use the RMSE, the root mean square error, to figure out which model behaved the best. And then the system is going to automatically register that one as the production model. So far, this linear model looks to be doing the best. I'm pretty sure this is going to end up being the one that gets automatically deployed to production. You can have a look. It is basically looking at time deltas up to the last three invitation rounds. Splitted is basically what I used to split between test and training data. You should also see on artifacts two folders. One is a figure of the actual experimental data, the way it was split, training versus test. You can see I split it in 2023. And then how the prediction for the model is doing, and the RMSE that resulted from that. As you can see, it's nice, like it's capturing this sort of ebbs and flows. It's good. And RMSE is a good metric to figure out more or less what's the delta between the CRS cutoff, because it's like a unit-to-unit comparison. So about 17 points delta between the actual score and the predicted one. Not too bad, because actually that's just you could hit those 16, 17 points by just doing slightly better on your English test, because you need to take the yields test or similar. You can just do that via just getting slightly better on that one. Okay, so it's completed. It is on. And so that means that if I go to models, see, there's now a model sent to production, and it is indeed that linear model. And also, yes, there's on the second folder, there is actually the fitted model as a binary file. So with that, we can move on and see what the web app is going to look like now. So now what we're going to do is that we're going to deploy Docker itself. We're going to deploy the web app in a containerized Docker image. So for that, we're going to do the next portion, which basically prepares internally, the requirements via pip, and then it deploys what we have developed originally with Flask in a Python script. You can investigate, if you're interested, in here, the deployment bit, what was behind the Docker container. All right, so the next step, let's see what we can do. We're going to test the app. Now this app is ported. And we're essentially going to run this file, test.py. It's basically calling localhost 9696 and the prediction app. It's asking for July 31st, 2024. And this should give you the same result as here, 535, which it did. You can also look at today, for example, August 15. And see, now you have a different value. Now we can move on. We just made sure that the web app is actually working. The last thing is via make, we're going to monitor the performance of our app. What it is doing is that it's going to also simulate Grafana and Adminer, where you're going to use Grafana to monitor and plot our variables of interest. And Adminer is just basically to visualize our databases. So now you go to Grafana. The username and password is just admin and admin. Nothing much about it. It will ask you to change it, but it's just local, we're simulating, it's fine. You'll go to dashboards. There should be a dashboard here already. See, now something is run. When I'm saying it's monitoring, in a real case scenario, this would run daily. And then you would have monitoring of the CRS cutoff value, the actual one and the predicted one on a daily basis. But we're just virtually simulating all of that. So we're just doing this on every second, it's just pretending it's like a different day. Now you can just ask it to date every 5 seconds or so. And you can see as time goes along, it's going to look at the actual CRS cutoff. If there was a round of invites on the day, it's going to look at the predicted CRS cutoff that our web app is suggesting. It is going to look also at the mean square error whenever there is an actual value, and also the standard deviation of that error and the drift between our test data and what we basically assume to be validation data. I'm essentially using, validation, actually anything before, like just the year 2023, because I didn't have much data. This is a very recent program, started in 2015, so that's why. And in general, we are using this right now to make sure that this goes down. Reason being that in 2023, the program changed quite a bit. There was a lot of policy changes, and so that's why there should be a lot of discrepancy. And then the system should be able to capture this kind of getting more regularized as time goes by. So for example, from the change of policy 2023-ish, as you go along, you should be able to see lower everything. So that's why, for example, drift is actually a quite high number. It should be way lower, but for now we're just using it qualitatively. And so yeah, the last round of invites happening actually 22 of April. That's the last time. You can just wait until it should look at today. You can actually ask it to plot this year so far. And it will show you the predictions of this year so far. And as you can see, it's just going to go slightly going up. The application is basically predicting that as time goes by, the next round of invites is likely just building up more applicants. There is more competition. So the round of invites, it seems like it's going to get higher and higher as time goes by. So the model has captured that. And this should be hitting that last value that we were predicting for today. We're going to wait until it gets there. And yeah, right now we just have these 4 metrics: the actual scores, RMSE, standard deviation, period. If you want to see the actual data on Adminer, you can follow the structures here. Adminer is on localhost 8080. Some PostgreSQL. Let's look at username Postgres, password example. The database name is just test. Doesn't matter much. And if you want to look at the data, this is how the actual data looks like inside the PostgreSQL database. you will have the predicted CRS for every single day. And whenever there was a round of invitations, then it should have an actual CRS and the variables that we look into. This should be updated too. So now it finished, and yes, it ended up as predicting 538 as the possible cutoff for the next round of invites if it happened today. So yeah, other good practices we have followed, we have done unit testing, integration testing, and linting, so you can just try that too. For example, unit testing. Unit testing is all related to making sure that it's scraping properly, that the data is being processed properly. It's mostly about how the independent variables are calculated, training is actually working, etc. You'll run. Integration test is making sure that everything works from beginning to end with our app, and that we're matching the value that we were expecting. It says everything's good. Linting is to make sure that all our Python scripts are following best practices on clean coding. And so, yeah, we get 10 out of 10, so that's good. And that's kind of it. So the last thing is you just want to clean up, you're done. You just want to close everything. Just basically Docker compose down to remove every single container. So everything should go away. With our fan miner, the S3 buckets should also leave, which by the way, now that we did it and I'm on free tire, the data did not persist. And then next up, basically we'll remove all the servers. It will remove MLflow, it will remove Perfect, and it will also remove the deployment server that was running on this machine locally. That's kind of it. You should be able to see that none of this works anymore. So it's really done because this is the Canadian website. One last thing, if you are running this on Linux, I forgot to mention this, there is one note for if you have an actual Linux workstation or you're running this on a Linux server. There should be a note here. Yes, here. When I'm doing MLflow, I am, and I'm containerizing everything in Docker. I'm basically asking the Docker container to look at the local computer, because right now everything is simulated, right? So I'm asking you to look at the simulated MLflow right now. And so the way that works is that there is an MLflow tracking URI as Docker, post Docker internal. In other words, this looks like this for this, the prediction app. In reality, this would have been like if this is actually deployed on AWS server node, this is like its own thing. If you're running this on a Linux computer, this doesn't work. This also only works on Mac or Windows. So if you're running this on Linux, change that please to your host IP, or try just this little IP address, which apparently Google says it tends to default and it sometimes works. That's kind of it. Just make sure that that is it. And that's it. Thank you so much for watching. Have a good day.